Volunteer as tribute.
Okay, appreciate that. All right, so let's real quick here. I just want to talk about what we're. Oh, all right. I'm just gonna put you guys for a second for the time being. All right. Okay. So goals, I can determine what the slope of a line means in a real life problem. So that's hopefully what you can do by the end of the day today. Hopefully most of you can do that at the start of the day today. But hopefully by the time you finish this density lab conclusion, you'll have a sense of how to do that. And we will be discussing this density lab conclusion on Monday. Okay, but what's our agenda for today? First thing we're going to do is just discuss that volume, mass, and density practice. And then we're going to do our conclusion for the density lab. Okay, so what are we doing right now? Well, you should open up the volume, mass, and density practice. And then what we're going to do is look at Hunter's example. We're going to list the things that Hunter did right in the chat first. After we list the things that Hunter did right, we're going to list the things that he can do to improve his answers. And then as you're watching all this, you should be making corrections to your practice. Okay, so let's open up Hunter's submission. Oh, and that, you know what, real quick. So days 3 and 4 are blue now. You should have completed everything in there. For day 4, I posted a copy of first hour's lesson on Schoology. So if you weren't here yesterday, or if like you didn't understand something, you can rewatch the lesson and get any notes that you missed. Okay, let's take a look at Hunter's submission. We'll go full screen. Should get my chat open so I can see what's going on with that. Okay. So this is Hunter's submission. Oh, I see the units are, I didn't realize they already put all the units on here.
Except for the last one.
Except for the last one?
Yep, which I did put on there.
Okay, good. All right, looking good. So let's start kind of at the beginning. What do we think about this first answer? What looks good about it? Go ahead and type it in the chat. Oh, I should, here, real quick, let's review. So what should you be commenting on as far as his answer goes? Oh, no, this one. Well, you should let me know if he has the correct number or value. That's important. You should let me know if he put the proper units on there. It seems like most of these already had units on there, so you shouldn't have to worry about that. And then is the work that he showed correct? So we're not going to spend a ton of time on this because I feel like you guys are going to have this assignment down better than maybe some of the other ones. But let's see here. Someone posted something in the chat just now. Eli Erdman said it seems correct. Andy showed work. Yep, I agree. Sam says it seems good. So yeah, if you look for this first one, he multiplied 10 and 8 and 5 together to get 400. And that's 400 millimeters cubed because we've got millimeters, meters, millimeters, and millimeters. Okay, so let's just take that as an assumption that you probably got all of these correct then. These in this first unit. Looks like in this first section, we're just multiplying them all together. And then that's going to get us our volume. So that looks good. Just as I scan over the other ones, looks good to me as well. Okay, so good. So let's scroll down to number 7. That one was good. You remembered that the units for number 7 should be 360. Yeah. 2 times 15 isn't 32. That's true.
Mm-hmm.
So 2 times 15, what is that?
30.
30, yep. And then 30 times 12 will get you up to 360. So for the units on this one, remember that centimeters times centimeters times centimeters is centimeters cubed. Excuse me, centimeters cubed. But centimeters cubed is the same thing as milliliters. So you're still good there. Let's go down to this next section. A huge graduated cylinder has 84 milliliters of water in it. When a rock is dropped into water, the new water level is 96 milliliters. What is the volume of the rock in milliliters? Yeah, that's fine. Yeah, guys, I haven't even graded this yet. So if you want to resubmit, like you see a mistake that you make, go ahead and resubmit. I know that I'm kind of behind on grading. So the plan is to be all caught up by Sunday. So everything that you've turned in this week should be graded by Sunday evening. If you log in on Monday and something isn't graded, send me an email. Okay. Good. So we take a look at this first problem, and yes, we want to subtract the 2 water levels. That will tell us the volume of the rock, which looks like it's 12 milliliters. Number 9, the beaker contains 155 milliliters of water. If a rock with a volume of 185 centimeters cubed is put in the water, what will the new water level be? So we know that the rock is going to raise the volume of the water by 185 centimeters, so that's why we're adding those together. So 155 plus 185 gets us to 340 milliliters. That looks great, Hunter. This one, just number 10, just contains one extra step. We need to calculate what the volume of the block is. And so we're going to do that by multiplying those together, just like we did up above. 4 times 3 times 8 is going to get us to 96. And then plus 100, because that block is going to add to the volume of the water.
It must be a pretty large beaker.
Yeah. Yeah. 200 milliliters. Yeah, it's a...
No. Because it's a block with like 8 centimeters. Oh, hi. That's the kitten. It's 8 centimeters.
Yeah, I see what you're saying.
Must
Yeah,
be pretty wide.
that would be a weird shaped beaker to be able to fit that. That's definitely true.
Can you hear her? She's purring so loud.
That's funny. Okay, but good. So then you're just adding 96 to 100, and that gets you to 196. You can either write it as centimeters cubed or milliliters. If anyone doesn't know, if you so on Notability, it's really tough to do superscripts and subscripts. So it's really tough to do the little 3 like as like an exponent. And so you can always use this caret symbol that Hunter did, and that just means that it's an exponent. So that means the same thing as, just give me 1 second here, as this. Let's get this big so you all can see it. 36. CM to the third means the same thing as CM like that. So if you ever want to use this as a shorthand to tell me, that it's supposed to be cubed, that's an okay way to do it.
The
If you have something to add.
superscripts are hard to do in Notability. But the subscripts you can just turn the font size down a bit, and on the iPads it's really easy because you can just tap the down arrow right above the keyboard.
That's a good idea. So yeah, so if you're trying to do subscripts, you can just turn the size of the letters down, and then that's
I
it.
just-
9 point is what I wrote it in, and then 4 point was like a pretty decent subscript.
That makes sense.
I just copied the character for a superscript 3 from the Wikipedia article for Cube.
Ooh, wow, that's a smart idea too.
That's a big brain idea.
Yeah, so you could probably just Google superscript or something like that, or just go onto the Wikipedia page like Eli said, and then you'll be able to copy it that way. Good idea. All right. Let's quickly go through the density here. What is the density of a material if 10 centimeters cubed of material has a mass of 40 grams? So this is one where you're going to want to use that density triangle. Did I put the density triangle on here? No, I didn't.
It's not on this one, but you had it on the actual lesson from yesterday.
All right. I don't have that up, but so density is mass divided by volume. What is one thing Eli could have done better on this one?
Hunter.
What is one thing Hunter could have done better on this one? Let's see it in the chat. Write out his answers. What do you mean by that, Mara? Because his answer is written out, but do you mean, write it out in a sentence? Oh, yeah, that's true. I do like it when people write it in full sentences. So you could say the density of the material is 4 grams per centimeters cubed. But Maya Ahmed, that's what I'm really looking for is didn't show work. Same thing, Sam. Yep, right. So I would really like you to show how you calculated the density. I know how you calculated it. You did 40 divided by 10. But when you get to more complicated problems, it really helps me help you if I can see where your mistake is. And so that's why I like people to show work.
Okay. For these simpler ones, I usually just do them in my head. Like, there's no extra steps. So
I understand, but on formative work especially, I would really like it if you just showed work whenever possible. It's just a good habit to get into. Okay. So you did the same thing with 12. We have a mass and a volume. We're dividing those masses and volumes. So 80 divided by 16 is going to give us to 5. And then look, we're keeping the units same. So grams are grams, centimeters cubed are centimeters cubed. And then last up for number 13, this one we have a volume and a density. So if you remember from the density triangle, mass is at the top. So to calculate mass, we need to multiply those two together. 200 times 1.2 is going to get us to 240 grams of antifreeze. The centimeters cubed are going to cancel out. Okay. Good. Thank you for volunteering, Hunter. I really appreciate that. Let's go back to the lesson real quick. Oh, that's the other class. Okay. So if you take a look in the folder, let me get out of here real quick. Week 1, day 5. So in the day 5 folder, there is a conclusion for your density lab. That's what you're going to be working on today. Let's go ahead and take a look at that together. I just posted that as a PDF. I thought okay. I thought I posted that as a Google Doc. Okay, but that's fine. We're just going to do it as a PDF and Notability. So it's only 5 questions. I just want to go over real quick. First question is, what is the purpose of this lab? If you can't remember what that is, just click on this link, and that should take you to the first assignment that we did for this lab. And the purpose is written on there. It's just called Daily Target. So that you can literally just copy. Now, one thing I do say is I answer each question in a complete sentence. Well, for a lot of these, I put a sentence stem on there. So really, you just have to finish it. Make sure for number 2, you're including units. And I didn't write this on there, but I would like it if you showed work as well, for how you calculated your graph. So what is the value of the slope of the best fit line on your density lab graph? So if you don't remember, go back and look at your density lab graph. You should have calculated the slope. Write it as a decimal, not as a fraction, and include units. So what does the slope tell us about the mystery red fluid? And then there's a little hint attached to there. So look at your units for slope and look at your notes on volume, mass, and density from yesterday. The units should tell you kind of what the slope means about the red mystery fluid. You're going to try to identify which fluid the red mystery fluid is. I've got 4 common fluids here and their densities. And then you're going to tell me how you can tell which fluid is the red mystery fluid. And then last up, if we put the 4 fluids into a graduated cylinder, so you can see I have a picture of this graduated cylinder here, they will form 4 distinct columns. Now, the reason why they're different colors is we put food coloring in them, so they're not normally like that. And so then they form what's called a density column. So you have to try to tell me which of these 4 common fluids, it's the same 4 from the table above, which of these 4 fluids is represented by which layer. And you're just going to draw an arrow. So if you think that the alcohol is the red layer, you're just going to draw an arrow from the alcohol to the red layer. Or you could draw it the other way around. I don't care which direction you do the arrow. So if you want to draw from the red layer to the alcohol, that's fine. Hint. The red fluid is not the same as our mystery red fluid in the density column. So this is a picture I took from the lab in the school yesterday, and they use different colors. So this red fluid is not your red mystery fluid. And if you're confused about that, just ask me for help. That's all I really have for you today. So I would like you to spend the rest of the day working on this density lab conclusion. We're going to discuss it on Monday. Unless a bunch of you don't turn it in which case you're on your own. So try to get it done, try to turn it in. If you have questions, talk to me. If you have questions about any of the previous assignments from this week, now would be a great time to hang around and ask me some questions. I would love to help you out. Okay, so also, if you weren't here at the start for attendance, hang around so I can get you in the attendance book. That's all I have for you. Good luck.